Okay, here's the solutions to the higher paper 2 for 2016. Question number 1, straight line question. State the coordinates of point M. Well, M is the midpoint of QR. So if we add the x's together in half and the y's together in half, then it automatically gives us an answer of 2, 4. For the second part of the question, find its equation that goes through P. Now the coordinates of P are 0, -4. So as we know that it crosses the y-axis at 0, -4, then we can just write down its equation straight away as y equals mx plus c, where we know the value of c is -4. All we need to do is work out the gradient of the line. And how we're going to work out the gradient of the line is we're going to use these 2 points here. So the gradient would be 4 take away -4 over 2 take away 0, 8 over 2, which is 4. So the equation for part A is y equals 4x take away 4. Now you can arrive at the same answer if you'd done y minus b equals mx minus a. Using the same gradient, using the point M or P, you should get the same answer as here. Part B of the question, find the equation of the line through L. Sorry, the equation of the line L passing through M, which is perpendicular to PR. So it goes through M and it's perpendicular to PR. So the first thing we need to do here is we need to work out the gradient of PR. And the gradient of PR would be 6 take away -4 over 10 take away 0, which is 10 over 10, which is 1. That gives us the perpendicular gradient then as -1. We know that it goes through the point M, and remember from our previously we had the M was the point 2, 4. So using that gradient and that point, y minus 4 equals -1, x minus 2, rearranging, gives us y plus x equals 6. And then for the last part of the question, show that the line passes through the midpoint of PR. So we need the midpoint of PR, so that's add the x's in half, add the y's in half. That comes out to be 5, 1. If the line goes through that point, then that point satisfies the equation, so we can substitute it in there. So 1 plus 5 for your y plus x should be 6, and indeed 6 equals 6. So we just need a wee sentence that says, therefore, line passes through 5, 1. Question 2, find the range of values for which the function has no real roots. So identify A, B and C. For no real roots, the condition that we're going to use is that b squared minus 4ac has to be less than 0. So plugging those values in, we have 4 take away 4 lots of 3 minus p has got to be less than 0. So 4 take away 12, add 4p is less than 0. 4p has to be less than 8, giving us p has to be less than 2. Question 3, show that x plus 1 is a factor. So we have our synthetic division. Coefficients are 2, minus 9, 3 and 14. X plus 1 is a factor, so we use x minus 1 on the outside. Add, multiply, add, multiply, add, multiply and add. A 0 remainder, that means that x plus 1 is a factor. Hence, solve the equation. So one of your factors we know is x plus 1. The other factor comes from here as 2x squared minus 11x plus 14 is 0, giving us x plus 1. When we factorise this, we have 2x minus 7, x minus 2 is 0, giving rise to the answers x is negative 1, x is 7 over 2, and x is 2. For part B, write down the coordinates of points A and B. Well, A is negative 1, 0 from what we did previously, and B is 2, 0 from what we did previously. The other one is 7 over 2, 0, but we're not asked for C. And the second part, hence calculate the shaded area. Well, the shaded area is the integral between negative 1 and 2 of the curve, which is 2x cubed minus 9x squared plus 3x plus 14 dx. Now if we integrate this curve, we get x to the power 4 over 2 minus 3x cubed plus 3x squared over 2 plus 14x, and the limits are 2 and negative 1. Now when we put 2 in, that gives us 16 over 2 minus 24, add 12 over 2, add 28, and then take away, when we put negative 1 in, a half, add 3, add 3 over 2, minus 14. First bracket comes out to be 18, second bracket comes out to be negative 9, and 18 take away negative 9 is 27, and we don't know the units, so units squared. Question 4, two circles, write down the centres. The first circle has the equation x add 5 squared plus y minus 6 squared equals 9. So its centre is change the x number, change the y number signs, so it's negative 5, 6, and its radius is 3. The second equation, x squared plus y squared minus 6x minus 16 is 0. Centre for that one, half the x number, change the sign, half the y number, there's no y number so it's 0, change the sign, and the radius of that circle is the square root of those numbers squared, take away the negative 16, so that's like add 16, 9 add 16 is 25, and root 25 is 5. Okay, so the answer to the question is negative 5, 6 and 3, 0. We're going to use the radiuses or the radii in a minute. Show that the two circles do not intersect. So we have this diagram here. So we need to calculate the distance between the centres. We know what one radius is, we know what the other radius is. If the distance between the centres D comes out to be bigger than R1 plus R2, then our conditions have been met. The distance between the centres is the square root of negative 5 take away 3 squared plus 6 take away 0 squared, which is root 100, which is 10. As 10 is bigger than 3 add 5, then the condition must be met. So the circles do not intersect. 10 is bigger than 8. The distance between the centres is more than the radii added. Question 5. Express AB and AC in component form. Well, AB is little b minus little a. Little b is negative 10, 18 and 7. Take away little a, which is negative 4, negative 6 and 21. No, it's not, sorry, I've misread that. Little a is negative 2, 2 and 5. And that gives us an answer of -8, 16 and 2. A to C is little c minus little a. That's your -4, -6 and 21. Take off -2, 2 and 5. And that gives us -2, -8 and 16. So that's part A. Second part of the question, find the size of the angle. Diagram is something like this. So cos theta is going to be AB dotted with AC divided by the length of AB and the length of AC. So take your previous answers and multiply them together. So -8 times -2 for the first part of components. Add 16 times -8 for the second components. Add 2 times 16 for the third components. The length of the first vector is square root 324. Length of the second vector is also square root 324. Gives us -80 over 324, and inverse cos gives us an answer of 104 degrees. For question 7, optimization question. What we have here is a shape which has been constructed from, oops, sorry, I've missed out number 6. Let me go back to number 6, my mistake. Right, number 6. We have a formula which says b of t is 200 e to the 0.107 t. Right, part A. How much material was at the beginning? So that is when t is equal to 0. So b of 0 is 200 e to the -0.107 times 0. This whole thing is 0. Anything to the power 0 is 1. So that just simply gives 200 at the start. For the second part of the question, how long will it take to double? Well, that's how long 200 e to the 0.107 t makes 400, or when e to the 0.107 t makes 2. If we want to remove the exponential from this side, we do the opposite to exponential, which is take the logs. So if the exponential disappears, you'll be left with 0.107t equals ln2. So t is ln2 divided by 0.107, which we can get from our calculator as 6.48 hours. Okay, now we can do number 7. Optimization. We have a diagram which is made up of 6 little rectangles. Now the total area is going to be 6 times each rectangle. Now each rectangle is y by x, so that'll be 6 times xy, or just simply 6xy. Now the length, the total length that's required is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 x's. Add on 1, 2, 3, 4, 5, 6, 7, 8, 8y. Our formula that we're asked to try and show that it's equal to does not have any y's in it, so we need to replace this y here. The question told us that the total area is 108. So if we go back to our first expression, 6xy equals 108. So y equals 108 divided by 6x, which is 18 over x when you cancel the fraction. So we now substitute that in here for the y. And that gives us the length as 9x plus 8 times 18 over x, which is 9x plus 144 over x as required. Second part of the question B, find the value of x that minimises this. So we need to take our formula that we just found, 9x plus, now instead of writing it as 144 over x, I'm going to write it as 144x to the minus 1. And we need to differentiate that, so find L dashed, 9 minus 144 x to the minus 2, which is 9 minus 144 over x squared. For maximum or minimum, this L dashed has to equal 0. So 9 minus 144 over x squared is 0. So x squared must be 36. So x must be 6. That's rubbish. 144 divided by x squared, let me take my time. Then that means 144 over x squared must equal 9. Cross multiply, 9x squared is 144. X squared is 16. So x is plus or minus 4. Now it can't be minus 4, that doesn't make sense in the question. Therefore, the answer is x equals 4. How do we show that it's a minimum? We have two. We can do that. We can either do the second differential. So if we differentiate our expression that we had for L dashed, now that was 90 minus 144x to the minus 2. If we differentiate that again, that gives us 288x to the minus 3. Or 288 over x cubed. And if I put 4 into that expression, so x equals 4, L double dashed is 288 over 64. That's a positive number. The fact it's a positive number is good enough to show that when x equals 4, you have a minimum value. If you don't want to use the second differential method, do a nature table as you approach 4 and leave 4 for L dashed, and you'll find it's this shape here, which also shows it's a minimum. Question 8, wave function question. We have 5 cos x minus 2 sin x equals k cos x plus alpha. Now if I do my expansion on the right hand side, that gives me k cos x cos alpha minus k sin x sin alpha. If we match up 5 cos x, there's the cos x there, minus 2 sin x, there's the sin x there. So that means that k sin alpha has to equal 2 and that k cos alpha has to equal 5. Don't have to worry about negative signs because there's a negative sign on each side in the right place. So we're okay with that. K squared is therefore 2 squared add 5 squared, which is the square root of 29. And tan alpha is 2 over 5. Alpha comes out to be 0.38 radians. Remember the question's asking for it in radians, so you need to make sure your calculator's on radians. 0.38 radians. So your original expression, which was 5 cos minus 2 sin x, is equal to root 29. So you put the root 29 back in here and 0.38 back in here for alpha. Second part of the question, find where the curve and the line intersect. So we put the curve, which has the formula 10 plus 5 cos x minus 2 sin x equal to 12. So that's 10. Now we have worked out previously that the 5 cos x minus 2 sin x can actually be rewritten as root 29 cos x plus 0.38. That has to equal 12. So root 29 cos x plus 0.38 equals 2, or cos x plus 0.38 equals 2 over root 29. From your all sine tan cos diagrams, we're looking where cos is equal to a positive number. So we're looking for here and here. From your calculator, that comes out to be the case at 1.19 and 5.09. Taking the 0.38 over gives us x as 0.81 and 4.71. Just need the x coordinates, so we can stop there. Question 9. F dashed of x equals 2x plus 1 over root x. Now we need to find f of x. So how do we go from f dash to f of x? We need to integrate. Okay, now before we can integrate, we need to write this in a form where we can do that. So write it as 2x over root x plus 1 over root x, which is 2x to the half plus x to the negative a half. So we are going to integrate this function here. So if I increase the power, I get 2x to the 3 over 2, and instead of dividing by 3 over 2, I turn it upside down to make 2/3, plus increase the power to be a half, instead of dividing by a half, turn it upside down to make a times. So that gives us 4 over 3 square root of x cubed plus 2 square root x. Now don't forget the plus c. The question tells us that f of 9 is equal to 40. So if I substitute the 40 in here and the 9 in for x, and I work all that out, I end up with my value for c is -2, and then I can plug that back in to get my final answer for the whole question. Question 10. Given that y equals x squared, add 7 to the power of half, find the y by dx. So how do I differentiate this? The half comes down, the bracket doesn't change, decrease the power by 1, multiply by the differential. The half and the 2x multiply together, I'll tidy up to give us x times x squared plus 7 to the power negative a half. Rewrite that as x over square root of x squared plus 7. Part B of the question asks us to integrate 4x over root x squared plus 7 dx. Now we know that the differential of x squared plus 7 to the half is x over x squared plus 7. Here we've got 4x squared, so it's only 4 times bigger, and therefore your answer is going to be 4 times bigger. So if I go backwards, my answer is going to be 4 lots of what I started with, x squared plus 7 to the half, and then add on my c. Last question, you'll be pleased to hear. Show that sine 2x tan x equals 1 minus cos 2x. Okay, a few things we're going to need in this question is we're going to need to remember that sine x over cos x is equal to tan x. We're going to need to remember that sine squared x plus cos squared x is equal to 1. And we're going to have to remember that cos 2x can be written as 2 cos squared x minus 1. So we're going to keep them in our mind. Right, so working on the left hand side, sin 2x, an expansion from the front of the paper, is 2 sin x cos x. Tan x I can replace with sin x over cos x. Now the cos x's will disappear, so I'm now left with 2 times sin squared x. From the middle section over here, sin squared plus cos squared equals 1. I can rewrite that as 2 lots of 1 minus cos squared x. If I remove the brackets on that, I get 2 minus 2 cos squared x's. Okay, getting roughly like what I'm looking for, but not quite there yet. This 2 at the front here, I'm going to rewrite that as 1 plus 1 minus 2 cos squared x. Okay, nearly there. 1, now I'm going to change the signs to a takeaway, so it's 1 takeaway because my answer said to have a 1 then a takeaway. So if I'm going to do that, I need to change the signs in here, so I'm going to have 2 cos squared x minus 1. We know from the last part up the top here that cos 2x is equal to 2 cos squared take away 1. So I can now substitute this in the bracket with a what? Oops, let's get the pen back. Replace that with a 1 minus cos 2x, and we've done what we were asked for. Last thing we have to do is part B, and that is given that f of x is equal to sin 2x times tan x. I need to differentiate that. Well, we've just shown that that function is equal to 1 minus cos 2x. How do we differentiate that? Well, the differential of 1 is 0, so it disappears. The differential of cos is negative sine, so that's negative of negative sine. Don't change the angle and multiply by the differential. The negative of the negative makes it into a positive. Bring the 2 to the front and you get 2 sin 2x. And that's the paper, folks.